Welcome to the Talking with the School of Transportation podcast with your hosts, Ian Campbell and Harnek and Ian. Let's get into it now. Welcome to the Talking with the School of Transportation podcast presented by Centennial College. I'm Ian Campbell, and as always, I'm here with Harnek and Ian. How's it going, Harnek?
It's going great, and today we're joined by Robert Lirette and Mary Greene.
Hello.
Yep. So,
Not just Robert Lirette and Mary Greene, though. These are some prestigious people in this college.
Oh, go on.
The great and mighty.
The great and mighty.
Keep going. Mighty.
Yeah.
Which one am I?
Both, yes.
And then also Robert Lirette is here too.
Well, thanks for having us.
Yeah, it's good to be here.
It's fantastic. And I'm excited about this one. This was my kind of topic, too. We're going to be talking about relays today. Mary, you're feeling like you're a little not prepared for this. You didn't want to prepare because...
I intentionally didn't prepare for this podcast.
Perfect.
I wasn't sure where we were going to go with it. Is this a lesson or is this just a conversation? I haven't been on a podcast before, and I don't really listen to them, so I really had zero expectations.
She doesn't listen to this one.
Yeeks.
You didn't listen to this podcast?
Well, I will listen to
Rob,
this
you
one.
listened to our podcast, right?
I did.
Yeah.
I listened to the one with Garrett, Colin,
And Joe Rogan,
and then the one,
Conan O'Brien.
and the one with Jay and Alistair.
Now that I
Nice.
see the stickers all over the college, that will remind me to listen, right? To tune in.
Yes, the stickers.
They're awesome.
We got new sparkle stickers
They're
because
so
they're cheap.
profesh.
Yeah, they're
cheap.
great.
Yeah.
With QR codes.
Well, yeah, I didn't
Eventually.
do that. Yeah,
Eventually.
One day.
We'll get there. We'll get there.
Yes. So, Mary, what do you teach at the college?
I teach, currently I'm teaching in our co-op diploma program. I'm teaching in a level 1 class. The courses that I'm covering right now are WPP, so workplace practice procedures. And of course, my super favorite class, which is electrical fundamentals.
And that's kind of why I wanted you on this one, because you teach relays in that course, do you not?
I will
At
begin
some
to,
point,
yes. It's sort of like a transition. So we start with, you mentioned that Mr. Nalepka was on the show, and you talked to Mr. Nalepka about magnetism. So in like Auto 106, the sort of fundamental course, it's sort of the introduction to relay is magnetism, right? And electromagnetism. So
if you haven't listened, go back a couple episodes and check out the magnetism one as well.
And Robert, you teach...
Currently, I'm in the day release, AST, and I'm actually doing electrical level 1 and electrical level 3. And that's for the apprentices.
It's perfect. So you're doing relays as well. A lot of relay stuff at some point.
Yeah, getting there. We're
I mean,
to
it's
go
like
over
3
just-
weeks in. So
Yeah.
No, it's like 5 weeks in.
I've got sections of electrical that I'm teaching, so we haven't gotten there yet.
gotcha.
Okay, so I know you've both taught relays before, even if you haven't taught them in your current with your current group of students. When it comes to explaining how a relay works or trying to teach the concepts behind it, where do you find students have a lot of difficulty? Is there any sections of it, or do they grasp it relatively easily?
I think that's a really great question. I think the biggest disconnect students have is why. Ultimately, a relay is just a switch. And why do we need a switch for a circuit that already has a switch in it, right? So students have a disconnect there. And getting them to understand that is the biggest challenge.
Okay, so I guess my question then is, if we already have a switch, why do I want another switch?
Great question, Harnek.
So the point of the relay is to have a lower current switch running a higher current load. So yeah, getting past the why do we have a secondary switch, and then understanding the difference in currents and not having the high current running to your switches. Then beyond that, the biggest disconnect is probably when it comes to actually testing, having the students understand it really is 2 separate circuits. There's a control side circuit and a load side circuit. So I always try and narrow it down to both of these are their own series circuits. So they obey the laws of the series circuit that we go over also in the course. And then that tends to make it a little bit easier for them to understand how it works and how they would diagnose.
Okay, so how does it work?
So I think to understand like the purpose of a relay, right? I always use as the best example I can think of is the part of the car that draws the most current, which is, of course, looking at you, Harnek
we're not
and Ian.
students. Yeah, we're not
The
students.
starter motor, right? The starter motor takes a huge amount of amperage, right?
Yes.
Larger than any component on the car. So if you think about the size of the cables that go from the battery to the starter motor, do you really want cables that large running into your dash and into your steering wheel and or up to your steering column, I should say? It's obviously a waste of energy. So once students start to understand that concept, okay, these would be the concerns that we would have with these large gauge wires. Then you can start to as soon as they accept, okay, I could see why I need a relay for this. Then we can start to explain the functions of a relay.
It's hard to explain it without actually being able to draw it out, because you've got, say, your 5-pin relays. So talking to people that know, you can say, okay, you've got pin 85 and pin 86. That's your coil of wire. That's going to, when we run a current through it, create the magnetic field. That's going to move the movable contact, which comes from pin 30, and then it's going to be touching pin 87A. Once I turn on the magnetic field, it moves over to pin 87, and then that's my secondary circuit.
Yeah, so breaking that down a bit, we have the two sides. So we have 85 and 86, which would be the coil.
Yeah, the control side.
On its own circuit, essentially. And then we have the switch side, which would be 30 and 87A, always in contact unless energized, and then 87. Yeah, that's great. That's probably the hardest part of this podcast, and maybe that's why
you can't visualize it. 100%.
And I think for the students that are driving home from the college right now, maybe just like frustrated, just trying to picture that, you know, you have 4 pins and what's happening, divide it in half with 2 separate circuits and try and walk through that. And that's really why I wanted to have this chat with you guys, because there's 4 different ways to verbalize a relay, and there's so many different ways to say things. And I think that getting a few different points where somebody might be able to really go, oh, that makes sense, what could happen here. So that's kind of my goal.
Gotcha.
Okay. Yeah, so you could just start by breaking down like each side of it, right? So I would say the control side, which is pin 85 and 86, that's your coil of wire where you're creating the magnetic field.
Okay, so
And slow it down for just 1 second, just so you can visualize it. If you think about a coil, what makes up a coil? What is a coil? This is the way I teach. I ask questions, so I need feedback here, guys. What is
we
it
were
made out
supposed
of?
to ask you the question.
What is a coil made out of physically? Break it down, unwind it. What is it?
Wire.
It's a piece of wire, and so it has a high amount of resistance or a very small amount of resistance.
Low.
Very low resistance. That's right. So, what kind of current is it going to take to pass through it?
Not very much.
Not very much current. Thank you, Harnek. You're
getting it.
doing so
I'm getting
good.
it.
A+ work.
I'm very proud of you. That's right. So you only need a very small amount of current to activate something that has a extreme amount of power, in that it's used as an electromagnet, right? Yeah, the potential. Very good. Thank you so much. Yeah, exactly.
So my question is this: Why with this coil of wire? Why are we running a power and ground through it?
So that's where we're creating our magnetic field to actually move the mechanical relay, to move the load side of the relay.
And something that I see with students a lot, it's like, what's the load in the control side? And they're like, there isn't one. And I'm like, okay, then you have a blown fuse.
Exactly.
There has to be a load. Like, what is the load on the control side
The
of the
load
relay?
is that
Great
coil of
question.
wire.
It has to be something.
Yeah. It has a small amount of resistance, but
There is resistance.
there is resistance. Yeah.
And that's that follows that laws of the series circuit. So if we can get them, again, if we bring it towards like diagnosis, if they're trying to diag a relay, they have to look at that side. It's its own series circuit, and it will follow the laws of that.
Yeah, exactly. And so Harnek and I were doing a little deep dive yesterday, and we were talking about what pins represent what. And so I'll be honest, I didn't care what pin 85 or 86 were, whether it was positive or negative, because it can both work,
Sure.
right? But is there a specific, is one pin specific for ground or power, or vice versa?
From what I've seen, like in experience, taking a look at schematics, 86 is usually the pin that they apply battery power to.
Great. And that's what we found too.
Yes.
Yeah.
However, okay, so you have to look at, right now you have to look at the coil as a magnet. And when you change the poles of a magnet, right, you're changing the polarity. You're not going to change the influence it has on magnetism. It's still, the magnetic effect is still going to influence, I should say, the switch or the 3087 side.
So you found 86 is always positive or generally positive?
I hate saying always and I hate saying
General-
never because there's
Right,
always
that's
going to be
exactly.
someone. But I have found that I've experimented with both.
Yeah.
And it influences the switch the same.
Of course it would.
From the experiments, the isolated experiments that I've done, right?
Yeah.
In your experience, 86 is usually power.
Yeah, when you check the schematics, it's usually.
I'm going to
86.
be really frank with our listeners right now. And if you've done the skills challenge at Centennial College, there's a
That's too frank. Don't give it away. Don't give it away.
Specific
The answer
way
is C.
that I want you to wire up a relay, and this may help you. So for those listeners,
Cheating. You're cheating.
you know what? I'm just getting more views, hopefully.
You are from the window right behind you. Huh?
That's awesome.
No, we got listeners at
You
the
have to
door
put
there.
a sticker on this door
we need a
so
red
they
light
know.
saying recording
Yeah.
and process, and that'd be fun.
When we get that popular. I mean, when you get that popular. Listen to me.
I would say that comment's funny because this is us. This is the School of Transportation. And it's not just our side. So far, I've had all of the dark side or all of the AST side on, but I'm excited to get some aviation and light rail and a whole bunch of people just chatting about stuff because the amount of knowledge out there is going to be fun to listen to.
Yeah, we have a good group, a good squad here at the college.
Squad. All right, back to relays.
Yeah.
I feel like I should say, are you feeling energized again?
We get it.
We still don't get it.
That's going to be all cut.
So I'll say me and Ian, when we did look this up, because, just as you're saying there, Mary, you typically do find 86 as a power and 85 as a ground. And we know as technicians, when you go across the industry, no manufacturer does the same thing as another manufacturer or consistently even with themselves unless they have to. Mm-hmm. And there was a standard. There was a standard referred to as the DIN standard. It was a German standard that was adopted by, other markets as well. And I think that's the reason why you tend to find relays do work the same, which is nice because then there's some consistency for when we're diagging them.
Mm-hmm.
And did I just make this up, or did Ford once use 1, 2, 3, 4, 5 to describe the pins of their relay? Did I make that up in my mind and just accept that as reality?
It's just
it's possible.
I'm
if you
pretty
go
sure there was a window in the
far
90s,
enough.
early
90s.
2000s.
Okay.
We're not all super
No,
young.
I thought you were gonna say, in like 1947.
No, I
on the
feel
Ford
like
Model
in the
T.
90s. No, I should have maybe done
Your
slight.
timeline's way off.
I should have maybe done a small amount of preparation for today. Maybe looked up that one fact before I laid it down. But I'm pretty sure there were some. I want to say it was Ford for sure, and maybe others that used the pin terminal numbers. 1,
And
2,
I
3,
believe
4,
they
5, and
printed
didn't
it
catch.
on the case, right? So if you look at the
Like
case
I
of
said,
the relay,
I don't know if I made it up or not. So let's start
So if you
there.
look at the case of a relay, it'll usually may give you a diagram.
Yeah.
And that's when they may have used something like that. And it doesn't matter the pin as long as you understand what's happening beyond it. right?
Exactly.
So,
Yeah, exactly.
I can imagine Ford would have done something like that.
Ford.
So back to that, 86 is usually positive, and that would mean that 85, Rob, what would
Your path to ground or your switch side.
Okay.
So if we're talking starter motors, when you turn your key, that completes your path to ground, which is wired to 85.
Yeah, you said switch side though, right? And
Control.
yeah, control side. I think because we just said that there's a switch side and a control side, and then you said switch
Yeah,
side.
That's
Sorry. Now
but that's what students have a hard time
Exactly.
understanding too.
We're
Because
on
even
the control side, but we're the switched side of that circuit.
So yeah, what you're doing is you're creating a contact or supplying ground at that point for the circuit to be completed, right?
Supplying a path to ground for
Yeah, and that's all to do with 85 and 86 is all to do with the control side.
and even the ministry terminology is control side. That's the coil, not technically the switch, even though control refers to a switch.
But that side is still in itself switched. And this is where it gets
100%.
easier to draw it out, right? I can run a constant power hot at all times to pin 86, and then 85 on the control side is switched.
Yeah.
And that switch in the case of starter motors is my key or my push button start, whatever it is.
Sure. Or the PCM controlling ground at that point. Yeah, depending on what's up.
So if you don't understand that there's that switch on the coil side, then the coil is always on all the time,
That's right.
right? So constant power ground, then
Constant engine cranking.
yeah, exactly.
Well, we
Always
have
ready to go.
Like walking through my
students-
level 1 lab.
We have students that when they're wiring them up for the first time and they're wiring up a relay, they forget to switch that switch side. So they just run power and ground through it. And
They're like, "It worked."
Yeah, but now I can't get my relay to change.
Okay, so now we have the other side of the equation, right? So we figured out this coil essentially, and on the other side, I believe, is where there's like a little leprechaun inside that makes something happen.
Yeah.
Yeah,
It is a leprechaun. I'm
that's how
glad you
most
brought that
stuff
up.
works.
I think
Yeah.
Garrett said it was the magic inside.
As an Irish
The magic
person.
inside.
The
Yeah.
magic
It is
inside.
The magic smoke. Don't let it out.
Yeah. So yeah, that sums up the control side pretty well. Just a basic series circuit that's going to create a magnetic field that can essentially pull over the next side, which is magic. So
Yeah.
what
well,
happens?
it's not magic because really what is the other side? What are the physical components of it? You take apart a relay, you take a lid off of a relay, and what physically are you looking at? What is it made out of?
Magic.
That's what we want to know.
Oh, well, it's a switch. What are all switches made out of? Can you assume, without actually taking it apart, what can you imagine that a switch is made out of?
So hard not to say magic.
No, that's true.
Okay, so on the other side, you've got, again, your 3 pins. You've got pin 30, which is going to be constant power. It's getting constant fused power. And then pin 30 is going to be, say, normally closed. So it's touching pin 87A.
Yep.
That's its rest position. That's where it stays.
On a 5-pin relay.
Yeah,
Because on a
5-pin
4-pin relay, you know, that rest may not be available.
Yeah,
right?
but it's resting against where
Something.
that
Yeah.
power, it's got nowhere to go. It's not wired up to anything past that pin. And then when we turn on the control side, then it moves over, it switches to the other pin. And then that's where our load side, that's where our load circuit is.
Can you explain the load side or the load circuit? What do you mean by that?
So the load circuit in this case is the starter. We were talking starters, right? That's the load in that circuit. So that's that second series circuit that's part of our relay circuit.
Yeah, so going back to the beginning where you said those wires that you don't want to run all the way through the car, can you explain how that, like, how would you set it up so that you have small wires and large wires within that relay? Does that make sense?
Yeah, physically speaking, a starter motor is located in the engine compartment.
Mhm.
And an engine is located in the engine compartment as well.
Are you sure?
The switch to activate them is located in the driver compartment. And so why would we want to run? Because a starter motor might draw 200 amps, say,
Yeah.
right?
And
We
you have
don't
a
want
4-gauge wire, or a very thick wire.
Yeah, why would we want to run a 4-gauge wire into the passenger compartment? It's unsafe. It's a waste of energy. And not to mention, it puts a huge amount of stress on components like the ignition switch or any switches that would be used. So I use the starter because it's an extreme situation, but really relays are used in any component that draws a large amount of amperage, which could be considered like 3 amps, right? Anything beyond like milliamps could be considered something that might require the use of a relay.
So we're talking door locks, window switches, trunk actuators,
Lights, horns.
headlights.
The horns is my student's favorite one ever.
Yeah, they love that.
Yeah.
So to reduce the stress on components like switches, to reduce the amount of wires and the size of the wires going into the passenger compartment, we put this remote switch inside the engine compartment. So now we don't have to carry this high amperage into the passenger compartment. We just simply keep it all contained in one area.
Mm-hmm. So what I'm trying to get at is we have small gauge wire or small wires, small diameter wires going into that passenger compartment to the ignition switch, then all the way back out to the engine compartment and into the relay. And starter relays are sometimes found quite close to the actual starter itself purposefully, so you don't have that long, heavy gauge wire, which is essentially money.
Cost,
right?
yeah, of course, cost is going to be a factor, right?
Yeah. So then that load side, you can use a heavy fuse, like a high rated fuse with a heavy gauge wire to give load to, or give the current to that heavy load, which would be the starter.
And that's coming off the load side of your relay.
So with a starter, for example, using that example is awesome because you're going to have two separate power feeds.
You do,
right?
yeah.
You have to.
Yep.
Right.
You do. Well, this is where I sort of get away from the starter analogy when you're
Yeah.
first talking about basics, because now we get into slightly more complicated stuff where you essentially have like two relays, right? A solenoid and a relay. So
Yeah. No, I didn't mean that. I meant fuse wise. So
Right.
like you can run power to 86
Oh, yes.
with a small wire off the battery, right?
Small
It doesn't
fuse,
and then you can have a small fuse on that. And then the large fuse would have to be on the 30 side because we're sending
Yep.
power that way, right? So
Yeah.
you can do a lot of different things and be set up differently to have the same results.
And I've sort of noticed a trend with manufacturers in recent years is, in the past, we usually used a fusible link in that wire.
yeah.
Okay, so serviceability was a little bit more difficult. But most manufacturers now tend to be using mega fuses on those high current circuits. And I think the last mega fuse I ordered was $150 versus the low side of the circuit, which would use, if we say a 5 amp fuse or a 15 amp fuse, what does that cost? $1
$3
for 5.
fuse or
Right.
Some manufacturers actually sell like mega fuse in packs. So you can't even buy just one. You have to replace the whole pack, right?
Yeah.
That's true. Yeah.
Yeah, so you get like a fuse array or something like
Yeah.
that, right? Yeah, and that only gets more expensive.
Yeah.
But that's why, the manufacturers are looking to cut the cost. I think, Ian, you're getting at as well, rather than have two current, two circuits that are working off a higher current where you need a bigger fuse.
So that's kind of building the relay now, right? We've got the two sides. We've got the control circuit and we've got the load circuit or the output circuit, however you want to say it. How would you go about diagnosing a relay or testing something if something wasn't working properly? Do you have any ideas?
Relays are great for diagnostics because it gives you sort of a midpoint of the circuit to test from, checking your powers and grounds, and then telling you sort of which way am I going? Am I on the load side? Is the load side my problem? Is the control side my problem? And then again, I always, and I hammer this into the students, they're both series
Literally?
circuits. Yes.
Like with a hammer?
Yeah.
Oh, so you
They're
have
both-
that's the J
Thor.
method.
We
Yeah,
call
the
him
D'Amico
Thor.
method.
We call them
Yeah.
Thor. That's perfect. Yeah.
They're both series circuits, and everybody gets the more complicated a wiring diagram, the students always get very, very overwhelmed, and they're looking at them. And I agree, some wiring diagrams you look at, it's 8 pages of information, and I can pick out, here's the 3 components that are actually involved in what you want to diagnose from the relay. Draw it on a piece of paper. Diagnose it. It's really only 3 or 4 wires. You can really simplify what the wiring diagram is, but having that jump off point from the relay is where I would start diagnosing, right? Do I have a problem on the control side? Do I have a
Yes.
problem on the load side?
So can we put that into practice? Let's do a little
I love
diagnostic
to use the scenario. Can
Yeah.
I
Yeah,
love
please.
to use the
So-
scenario where the customer is driving in traffic and they get cut off and you've just serviced their car and they go to push their horn and their horn doesn't work because then the customer is super enraged and immediately thinks that you're responsible because you just did an oil change on their car. So obviously you did something to their horn. So they pull back into your shop and they're even more mad because they are road rage and their horn didn't work. And you have to quickly diagnose their car. And I always ask the students, where do you start? And a lot of the students will say, I'll start at the switch. Does the switch work? Like the horn switch. So you're looking, okay, where is the location of your horn switch?
The hardest thing to check.
Right.
Yeah.
Yeah. So how long is that going to take you in labor to diagnose a switch when you have to take the steering column, get access that horn switch? How long did it take you? How angry is that customer now? What does that bill look like? Okay, let's try again. Let's try something else. Okay, the horn. Maybe it's the horn itself that doesn't work. Let's go to the horn. Okay, where is the horn located?
Remove the bumper.
Behind the rad.
Right.
Yeah, exactly. Exactly. So before we jump into that, let's find that middle ground. There's an access port right underneath the hood that have great contact points for diagnosis. Right?
Yeah, definitely.
Yeah, and even whenever I talk about diagnosis of any electrical circuit, I always say you want to try to cut your job in half. And if you can find a point where, and I normally am referring to intermediate connectors, but this is the same idea. If I can isolate or remove half of the circuit, that's half of the car has been eliminated essentially if I'm trying to trace something. And that's what we're using the relay as, right? So we are eliminating 50% of the circuit if we've tested one side is good and
Exactly.
one side is defective.
Exactly.
So if I come to the example of, let's say, horn and op, so that's where with what we're discussing. What am I doing with that relay now? I see the relay. I've taken the cover off. It says horn relay. Now what do I do?
So we want to know which side of the circuit is. Is it a switch or is it the horn?
And
so can you do you have a spot right there at that relay terminal where you can activate the horn? Send power manually to it to activate the horn. Close the switch, as it would be.
Okay.
Do you?
How do I do?
So she's giving a real answer, like a technician.
Sure.
The quickest, easiest, cheapest way: swap the relay.
Okay.
Yeah.
Put another relay in it, and that's coming from working.
I would never tell my students to do that.
That's coming from working in flat rate shops.
Sure.
For years and years and years. The quickest, easiest way, and tool companies, Snap-on, Mac, they sell tools that plug into relay ports that actually have switches on them for us to manually test these circuits, right? So you can see, okay, is it a relay? Is that bad? And that's, if you go back to what Mary was saying about, the customer comes back and they're mad and you have to diagnose it as quick as possible.
Well, I want to continue with that scenario where you said, you can get a toolkit or something, or even if I swap the relay.
Yep.
Let's say I go and I take another relay, a known good relay.
Thank you. That's the word you're looking for. Known good, because otherwise it'll bite you.
That's in service information. Take a known good part.
I take a known good relay
that.
and I install it, and my horn still doesn't work. Okay, well, I know the relay's good, but I can still use the relay where, that relay point to continue in my diag.
Yes.
And I think that's what Mary was talking about earlier, right? So
just
how do I do that?
Off and manually.
So now you're looking at, am I control side or am I load side? So I believe what we were saying before is you can, if you look at the relay and the pin out of the relay, you know that, say, pin 87 is going to be the power feed wire out to the horn.
Right.
So you can actually use a fuse jumper and take power from pin 30 over to pin 87. Is the horn working?
Perfect. And now if the horn beeps,
then I'm looking at control side.
The control side.
Which is totally fine if you understand which is pin 87. Right. And something that I struggle with doing is putting power to anything. Because you could have a module that's controlling the ground side of that. And if you got your jumper and go, oh, yeah, I think this is it.
Wrong
pin.
And then you've blown a module. So, and understanding a wiring diagram, as you said, is huge. The way I would recommend apprentices start with is checking for the powers and grounds with the test tools, right? Do we have power on our, pin 86 and pin 30? If we have those powers, we know that's good. Then when activated, do we have ground on pin 85?
And that's the key. When activated. Exactly. I feel like that's a thing people will make mistakes on. If you don't push the horn switch, then you don't. It's like that. What Rob was talking about earlier, the switch on that coil side. If you don't do that, well, then now you don't have what you need to make the coil work.
So that's taking everything you went through for diagnostics, right? Checking powers, checking grounds. That's taking the long road, but that is the right way to obviously diagnose. And then you've got steps beyond that. Okay, if I don't have a power, I don't have a ground, how am I going to chase that down? Am I voltage dropping the wire? Am I checking for continuity through the wire? I know that some instructors don't like continuity checks.
Yeah. I love continuity checks because I'll tell you, I like it as is the wire broken or not?
Yeah.
And that is sometimes useful when you work on a certain type of vehicle that often the wires are broken.
Chrysler's.
Often. No.
Oh, sorry.
So
Dodges.
Chrysler's not sponsoring this, right?
Not anymore.
Not yet. But it's useful as is that wire broken or not, which is great if something's totally an op. Right?
I don't not like continuity. There's totally a time and a place for it.
There has to be continuity.
100%. Yeah. I teach my students to test for resistance, which is a continuity test.
For sure.
Yeah. So I never dismiss it. I just don't like the beep. tape on the multimeters.
I
make them
always
do
say
resistance.
you only use that when you're upside down under the dash and you
Yes,
can't see your meter.
exactly.
Because
Yes.
even as a technician myself, I get annoyed with the beep. Like, you're like
I turn it off. I turn it off.
I've just been, I found that it's always been the quickest and easiest way, and 90 to 95% of the problems were where I've worked, a broken wire, an open wire.
That goes to process too, right? Like just the way you process it in your brain. Like everybody has a different way to diagnose something. And Mary, you said this too. Like you said, you go straight to the relay because it's your easy test point. In my head, I'm like, nope. I'm going to reach my hand down there, grab the horn wire, and see if
wiggle
I have
it.
power and ground. No, see if I have power and ground because that takes it's the final straw.
but I will say though is if you can't get to the horn,
if I
right?
can't get it,
I wouldn't-
Yeah, but and
My fingernails would stay clean.
so there's a CFQ there's a CFQ test question that kind of talks about this, and it says, it's a horn, it's the same sort of thing, and the answer is the relay. And I'm like, I don't think that way. I'm going straight to the bottom and then going to test that way. So that goes to that process of like the way you think and if it works for you. And I think continuity works for some people. I think voltage drop works for other people, and it's just kind of like that.
I think it also has to do with the ministry standard where we're looking at every make and model. We're not just looking at
That's true.
the easiest. Okay, I worked on a lot of GM, so accessing horns on, say, okay, I won't say all of them. Some of them can be very, very difficult.
Of course, yeah.
Okay,
Of course, yeah.
very, very difficult. You can't just reach down. Where are you reaching to? Right?
You can bend some fenders.
Right.
They're plastic.
GM's
Right.
not sponsoring us anymore either.
Some technicians do it different, right?
That definitely made me cut out. Yeah. I swear
About
I'm not
cutting
a hack.
that
I
workload
swear
in
I'm
half.
not a hack.
About the flat rate mechanic.
I just
You're
wired in
back
my own
into
horn. Here's your switch, sir.
What works for you, right? Like you might be okay with jamming your hand and bending your arm in 8 different ways to get to a plug.
Yeah.
Some people would go through the trouble to pull the bumper off and pull the rat out and pull all these different things out.
Those
just
people
to
would be
change your
wrong.
horn.
You're right.
Yeah, absolutely,
You're
they
right.
would be wrong if the way you look at it. But some people are okay with working past components, and other people want to, take out as much stuff as possible to actually get their components out.
For sure. Yeah. And going back a little bit to the adding power to something is a great tool
long
when
as
done
you know.
correctly.
Correct.
And then a power probe, I bought a power probe as an apprentice, and I was like, yes, this is the best tool ever. I used it once.
Yeah.
Like I just don't use
Really?
it. Because
Still use mine.
I've never liked the
amazing.
idea of it. I'll be
need
honest
to
with you.
add
I've never
power
liked the
to
idea
anything
of it.
unless I have used it only to roll up windows.
I was going to say to wedge
Sure.
open a door
Hey,
or
that's a
something.
good idea.
Yeah, like only to like roll up windows when you needed to, or something like when the door's disconnected or whatnot.
Yeah.
But beyond that, I never really add power. I always go the other way because
Safer.
I'm nervous about that module. So
Yeah. You have to be really good at reading
I
schematics.
would recommend our apprentices to understand the rest of it first,
Yes.
and then go when you get confident to go to that. So
Yes.
We're not the same. I'm
And
not
even
nervous
that-
at all.
Even that note on you have to be really good at reading schematics. Sometimes, and again, working at private shops, working on all makes and models, like schematics aren't always
Volkswagen.
accurate.
Come work at a dealer. They're not accurate
You know
either.
what? Yeah, and I was just
So-
talking.
We're not going to get
the
signed
other
up by
day.
anybody.
No.
So it is. You do very much have to take your time and sometimes use multiple sources.
I've worked on cars where it says these schematics. It's like warning: these schematics will be wrong. The colors
will die.
not match. And sure enough, you look at it and you're like, none of this matches, and it's an imported vehicle.
Yeah, right.
And good luck to you. Basically, is what they're saying.
Yeah.
Yeah. So if you understand how the circuit should work, though, you can almost move past the schematics to a degree.
Yeah.
Right.
The complications are becoming greater as cars become more modular, right? More reliant on modules. And even actually the uses of relays are decreasing and decreasing as we just have straight
Many of
module to
them
are
component
still-
communication.
yeah.
Or the relays are internal or
Yes.
part of the fuse box
Incorporated
assembly
into the
or a
module.
module,
Yes.
right?
Yeah.
So there's no external relay, but it works in the same way, right?
All
And the
right.
purpose is the same.
So dyeing a relay is a good test point for the circuit, as
Yep.
you guys said. And so we have a power and ground on
Yep.
one side.
Yes.
Pretty straightforward. We should have a constant power on the other side. And then once the switch is going, we should have power going through it, right? A fairly straightforward
Yep.
explanation. Anything else you think on that dyeing just off the top of your head? Or
Again, like just tips for diagging, how you would diag. again, with any electrical circuit or even diagnostic charts that come like with codes or with problems, never look at anything unless you've got your wiring diagram, and study the wiring diagram, understand it. If it's confusing to you, which often they are, one thing I learned like way back in my apprenticeship days was take a highlighter.
Yeah.
Highlight the things that are important. Highlight the things that are going to your relay. That's your test point. And then assuming you're in the trade and you know how your meter works, and you can start checking for powers and grounds and things like that. I'll show you, Harnek, don't worry. It actually becomes extremely simple. And electrical is one of those things everybody comes in and they're like, oh, I don't like electrical. I don't like electrical. And I always tell them, you better learn to like it, because everything is electrical. There's nothing essentially in a car anymore that is a lever or a cable.
And, I'll say one of the probably greatest things my service manager did when I was an apprentice is he threw me a lot of complicated electrical stuff. And just like you said, you better learn to like it. Is I was losing my shirt. I was flat rate apprentice, and I was losing my shirt on it. And rather than highlighting the wiring diagrams, I started making my own. So I took the diagram that was 4 pages, and I took one blank piece of paper, and I just drew it all out for the circuits that are related. And that made a huge difference in understanding how the circuits work and how to diagnose.
It's a great way to do it. And then you can draw on the paper, hey, I had continuity on
That's
this wire.
exactly what I did.
This here, that.
Yeah.
Because you're not going to remember 2 hours down the road chasing wires.
8 pages later.
Yeah, hey, what was that? And if you can go back and reference.
Yeah, and that's why I love like circuit names. Like I push that too, like A111 circuit. Oh, I had 12 volts because I don't remember. Exactly, right?
Yeah.
Like it's super helpful when you're doing that kind of stuff.
It also helps when we're writing
stories
at the end.
You have to know.
Well, you have to. Yeah. To justify your time. So, relays.
9 hours to diag that relay.
Yeah. Swapped it with another one.
I had to
Ian
take
shove
the
his arm
bumper
down there. Yeah.
All right. What did pin 87 say to the light bulb?
Oh man, dad joke time.
Yep.
What?
It's time to get lit.
Yeah.
At the end of every episode with the guests we have on, we have a couple questions. So the first question I have for you, if you could switch into anyone's shoes, dead or alive, for a day, who would you choose?
So
Rob
would you
can go
be for a
first.
day?
Yeah, Rob, you can go first. Mary's face is like, why would you ask me this and not let me prepare?
And Rob's just like, I don't know, like a
I have
2-year-old
so
younger
many
version of me.
inappropriate answers.
Oh, no. It can't. Has to be appropriate.
I was literally gonna say my daughter.
Okay.
You're saying who?
You'll figure that out in therapy later on, I guess.
Could it be me at a younger age so I can like
See,
relive
that's
a certain
exactly
day?
what I said you were gonna say.
I don't.
Well, I want to relive a certain
Do
day.
you mean Athea?
You're that conceited, are you?
Okay, I'll pick somebody else.
Anyone, you could be
anyone.
anyone.
Yeah.
Anyone.
Which scientist would you like to be?
Everybody wants to be
that's what
scientists. I don't
everybody's
understand
saying.
it at all.
No, I don't want to be a
I
scientist.
want to go back when electricity was invented. I'm
I
like,
was
why?
thinking
That would
like
suck.
Janis Joplin or
okay.
Bob Dylan.
Yeah, I want to be
or
Janis Joplin, whoever
no,
that is.
I could that.
Yeah.
Get your own.
So, like-
Janis Jalopky.
So, was there a specific concert you want to be at? Or?
Sure, like who would want to be at Woodstock? But
Okay.
like, I just think that time that she was alive, the movement for feminism, her
cool.
drive, her independence, like the path that she paved for female musicians, and all the parties she must have attended. Would have
Fair.
been
Yeah,
You
for
only
all
get
those
one
same
day.
reasons, I
Fun.
also want to be
Fair
Janis
enough.
Joplin for it.
That's a great answer. Great answer. One of the best so far, actually. Everybody else kind of,
Yeah, she's
you're
like, she thought
welcome. No
about
problem.
it. Yeah.
So, Rob, do you have one, or are you at a younger age?
Does it have to be like a real person?
No.
I mean,
Okay, then I'll take Thor. I want to
Thor?
throw hammers.
I thought you might be Archer.
I want Thor now.
Yeah, no, I want to be Archer from the cartoon.
Oh boy,
I knew he would.
Everything always works out.
Okay, Rob, let's ask this one last time. Who would you want to be? One person, one day.
Thor and Archer, I said. That's one person.
One person.
Archer.
I love that. All right, and the last question is: if you could pick one vehicle to have for a day, anything in the world, plane, trains, automobiles, car, anything you want,
For one day, and then you have to give it back.
and then you have to give it back,
you have to give
what
it
would
back.
you take?
1999 Toyota Tercel.
Was that your first
He
car?
misses that thing.
No, it was my third car, and I regret every day getting rid of it. It's
With
dying
no
on a farm
horn.
somewhere.
Yeah, slightly overeating.
No, that car's been on a farm for the last 10 years.
Oh,
it's,
okay.
it's got like trees growing through it, and I bet you it still starts.
Is that like, did someone tell you it's going to a farm and it's actually at a scrapyard? It's like,
Just like all my childhood pets that went to live on a nice farm.
my Tercel's living on a farm.
No, I sold it because I thought I was getting something better, and then
And you did.
I missed that car.
Really? That's what you pick? Your 1999 Tercel?
It was the best car, man. It's
Okay.
bulletproof.
I love it. So, Mary, what car would you choose?
I would probably have to pick a supercar like a McLaren or a Bugatti. And I realize I can only choose one, so I would choose a McLaren because it's been my
That's
favorite forever.
Garrett picked that as
No.
well. Yes.
He picked it first?
Did he? He did pick a McLaren. Yeah.
That's not fair.
Yeah.
What?
Can't have the same
Too
car
bad.
as Garrett.
Yeah, I will. I'll drive it faster than him. Can I race Garrett for a day?
I think that's a great idea.
Yeah. Can we have it on the same day at the same track?
McLaren to sponsor this?
Yeah, we
Yeah,
have
if
a few students from former students at McLaren right now. Maybe we can make that happen.
Vroom, vroom. Let's do it.
Yeah, just go on a PDI. Great. Well, that's awesome. That's the podcast. Thank you, Rob.
Thank you so
Mary.
much.
Thanks for
That was a
having
lot
us.
of fun.
Thanks for joining
time.
us.
We hope that you can understand relays a little bit more. As always, if you have any questions or thoughts for podcasts, please send it to icampbell@centennialcollege.ca. And if you follow this thing on Spotify or Apple Podcasts, that would be lovely. So until next time, thank you for hanging out with Talking with the School of Transportation podcast. We'll see you then.
And if you're one of my students, there will be a quiz next week.
Bye, folks.